Welcome back. This is our video for, I guess, more problems involving inscribed angles in a circle. If this is your first time watching a video here, please leave comments and questions below in the comment section. And if you like the video, please leave a like and subscribe to the channel. So let's go to question number 1. And so in circles O, diameter AB is drawn. Locate C anywhere between A and B on either side diameter, and draw line segment AC and line segment BC. So let's pick let's pick a point C. Let's make it somewhere over here. Does not matter. It does not matter. And so we're going to connect the line segments in this situation. Okay, here's this segment and here's this segment. Okay. Now, what type of triangle we're going to have? Well, consider this case. All right, we know that angle ACB is an inscribed angle. Okay, and so we know that the measure here, of arc AB has to be 180 degrees. Why is this the case? Well, since AB is diameter, it is going to separate the circle into two equal parts. Therefore, this must be 180 degrees. Okay, and since the measure of angle ACB has to be 1/2 the measure of arc AB. Now again, why is this the case? Well, because angle ACB is an inscribed angle, and an inscribed angle's measurement is 1/2 the measure of the arc intersected. So that will mean in this situation that the measure of angle ACB is 90 degrees. Well, if that's the case, triangle ABC, or ACB in this case, is a right triangle. Because if an angle, and if one of the angles of a triangle is a right angle, then it's a right triangle. Okay? We should type it out. If a triangle has one right angle, then it is a right triangle. Okay, so there you go. So that would be our reasoning for what type of triangle it is, why it's a right triangle. Okay, question number 2. In circle M shown, where the center of the circle is SM, points A, B, and C have been located such that the measure of angle AB, measure angle B is 180 degrees. So let me see now. I just want to edit this a little bit so it's not too confusing. Oops. Popped up, 108 popped up twice. All right, so locate point D anywhere. So again, it was one of these things where we're going to put D anywhere. And I'm going to put point D somewhere over here. Okay, so here's point D. It says here to draw your line segments. So I'm going to connect, and in this case, I should have also labeled the angle measurement. So here, let's A, here's A, here's B, and here's C. Okay, and so we're going to connect the line segments. And again, it didn't matter as long as, in this case, as long as D was somewhere, I would say, it's kind of fussy here. Let's put it over here. D was somewhere, I guess, opposites of angle B. So now what we're going to do is the following. All right, so what we need to do is use a protractor, find the measurement. So here I'm going to grab a protractor here. Okay, so on-screen protractor. And so what we're going to do is we're going to measure the angle D. So let's bring this over here. I'm going to put the with the crosshair right where the vertex D is. Now we're going to move. Oops. Now we're going to move this, rotate. Oh, I can make it bigger if I want to as well too. Okay. Now let's move this around so it lines up. Okay. And so now, probably want to find the measurement here. Oops. Oh, semicircle's fine. So we want to find this measure here. All right. And let's see now. Usually it lets me be able to find the angle, but we can see in this case, I can make this a little smaller. Oh, nope, I don't want to move this. Okay, you can see that if we were to extend this segment here, where is that? Oop, that's not it either. Okay, so it worked out really well where I actually got a, um, the part to show the angle measure. Let's see, maybe if I do it this way. Oh, here it is. That's where it is. Okay, it's on this side here. Okay, so now we're going to measure angle D. So angle D is going to go this way. And we're going to see in this case that's about, it says about 73 degrees, but it should be 72. So in this case, we're going to put in here the measure angle D we found to be 73 degrees. However, does measurement agree with the theory, the theoretical value of what it should be? Well, here's the thing. Okay, so we found, so I found, let's see, actually it is, let's see now. Does it look like here's 70 degrees, 71, 72. It's not 72 actually, so it should be a 72. All right. So our answer should be 72 degrees. Okay. All right. Fantastic. And so now maybe I can see if I can remove this here. All right. Okay, maybe not. All right, so does the measurement agree with the theoretical value and explain? And the answer is yes, okay, all right, because if a quadrilateral is inscribed in a circle, the opposite angles will be supplementary. See, this is the theory that we talked about probably the lesson, and the reasoning is this. Okay, if I can just see if I can maybe here we go. Get rid of this here. Okay, so why is this the case? Well, so what we have in this case that the measure of arc ADC has to be twice 108 because again, angle ABC is inscribed angle, and so that would mean here that our measure arc ADC should be 216 degrees. Therefore, the leftover arc here, arc ABC, well, that's 360 minus 216, and that would be 144. And so angle D being inscribed angle is half of that, so it should be 72 degrees. And so the idea is that we can work it out this way, but theoretically, the inscribed quadrilateral in a circle will have its opposite angles equal to the opposite angles be supplementary because the two opposite angles encompass both intercept the whole circle. The sum of the two arcs make up the whole circle. And half of 360 is 180. Therefore, the sum must be 180 degrees. So that's kind of where it's coming from. All right. So here we go. In circle A, shown below, we see in this case BC is parallel DE. So with a little parallel symbol here. And in this case, the measure arc BC is 58 and the measure of arc DE is 142. Determine the measure of angle CFE. We'll call that X here. Well, a couple of things. We know that if two chords are parallel in the circle, then the arcs intercepted by them in between them must be congruent. So I'll call this measurement X and this, oh no, we already call that X, so let's call it a different letter. Let's call it Y. How's that sound? Okay. All right. So here, call this Y, and this must be Y as well too. So we know that 142 plus 58 plus 2Y is equal to 360 degrees. Well, 142 plus 58, that makes 200, I believe. So 200 plus 2y equals 360. That means 2y is equal to 160. Y is equal to 80 degrees. And so this measurement of arc CE is 80 degrees, as well as arc BD. But we're looking for the measure of angle CFE. Well, again, measure angle CFE is equal to 1/2 the measure of arc CE, because the measure of inscribed angle is half the measure of the intercepted arc. So we have 1/2 of 80. This must be 40 degrees. Okay, so it's here you have to find angle measures, have to find arc measures as well. So that's kind of important. And so these questions are going to be not so much of a straightforward single-step question, but here they're going to be multi-step questions. Okay, now let's go on to question number 4.